All right, in this video, we're going to talk about springs. So, springs, you could typically categorize it into three different types. You have the compression, where you have to compress it to generate force that pushes back. You have extension, which you have to pull it, and then the force is going inwards. And then you have torsion, which you have to rotate. So I would typically classify it into those three categories. But you can see here are some examples that you would typically see. So these are the compression springs that I talked about here. You have some very special types that have a conical shape. So this is good because when you compress it, it actually sometimes it goes down to a very small height because it's like a spiral. So it kind of everything will just the circles will form side by side when you compress it down. And then you have these type of extension springs. So usually extension springs have like little hoops in the end for you to hook onto something. It could be like a screw with a hook or any sort of uh, anything that sticks perpendicular to a circle. Those could be different types. And then you have these torsion springs, which you see in like hinges sometimes. You see like two flat ones, and some could be forced to. You could feel the force if you're either opening or closing, depending on how you orient it, or depending on like what angle you purchase it. And then you have some like stacked wave disc springs. So these are just more compact form. But basically, you have your famous equation F equals kx, as you recall in physics. So you could kind of calculate based on your displacement. You have some stiffness that you want, and then maybe some force output. So based on those criterias, you could decide on what spring is suitable for your application. Okay, so of course, size is important too. So you could choose the exact length you want, maybe OD, ID. You have N type depending on how you want to terminate your spring. So I would say those are all pretty important factors. And then the wire diameter will typically influence the actual spring force. So typically, I would say the driving constraints would be your force you want to get or the amount of travel, and then from there maybe the size of the spring, and then the rest will kind of follow. So you would go ahead and just choose it based off of that. Here we will go through some examples on how to use this conical compression spring because I find this one pretty cool. So let's see if I click this. Okay, so if we look at this, right, it says there's like a max load of 4 pounds. Then compressed length at max load is 0.13. So you can see it compresses a lot. Let's go ahead and open up one of the drawings here, or the part. So you can see originally it's 0.25. And then when you compress it, it goes down to 0.13. So it actually compresses a lot. So let's go ahead and take a look at how you might use this spring. So go ahead and download this. And we'll put it inside our Solidworks folder, or actually the mechanical components folder. And then inside our springs, we'll go ahead and save this here. And we'll go ahead and open this up. Okay, so voila, you can see our spring. And the thing in SolidWorks is when you're dealing with springs, there's some ways you could flex this, but right now we're gonna leave it as unflexible part here and just use it as is. So typically to use this in assembly, sometimes you might need to confine it either in the outer diameter by having some circle or some inner diameter. Okay, so we'll just show you a simple example of how you might constrain this. So you might create a block, right? And in my top plane, I might start sketching something. So the spring is not very big, so we'll just go ahead and make this perhaps 2 inch by 2 inch block. And we'll go ahead and extrude this by, let's say, 0.5 inches. And we'll save this and call it spring block. Okay, so if we come back here, we see that this is 0.48. So you just want to give it a little bit of space to contain it on the outside. So I'm going to make a hole that's zero point 0.5. So I'm not going to use hole wizard right now, but in practice you can. Certain applications is better, but here I'm just going to use a simple extrude cut because it's a little bit faster. And I will extrude it down zero point 0.5. So zero point 0.5 will go all the way through because I made it pretty thin. So let's just do 0.25. And if I make an assembly, I'm gonna first put the spring block, put a pin here. Okay, so with these springs, it's kind of funny because they don't quite have nice planes for you to mate. You can see here's the top plane, right? So maybe we want to have a reference plane, and you could be exact, or you could just drag it. But we also know the height, right? So we could check the height, which is according to this is 0.25. So we could offset this by 0.25. You can see obviously this is in the center, so it's a little bit off. So we could do 0.23. It's a little bit better. So we'll go ahead and save this. And if I save it, I could go ahead and come here, go to this plane, and then I could mate this inside here. And you probably want to flip it. Okay, so here we have it flipped, but now we want to center it. So if you want to center it, we could come back to the spring. Let's see, spring is here. So we come back to the spring. We could see that in the right and front plane, perhaps we want an axis. And then that will allow us to constrain it more properly if we take the axis. Okay. So now we have a spring inside our assembly. And then, so typically, like I said, you would have either the outer walls or inner walls to hold it. Here I'm using the outer walls. And then you might have something that goes on top of this block. Okay, so if I take a section view to see how this looks like, you can see our spring inside our assembly. So there's a myriad of things you could do with this. Maybe you have a button. You could have something that goes on top that slides up and down, and then the spring will come down as it slides. Okay, so hopefully this gave you an idea how to put a spring inside assembly. And if you found this video helpful, give a like and subscribe, and I'll see you in the next one.